My dear students, in this video I am going to introduce theoretical distributions. In the theoretical distributions, our first distribution is binomial distribution. A binomial distribution is nothing but an experiment having two outcomes. That experiment is called Bernoulli trial. Bernoulli's trial. The binomial distribution is an experiment in this distribution, an experiment involving in this distribution, and that experiment is called Bernoulli trial. Bernoulli's trial means any random experiment having two outcomes. Bernoulli trial is any random experiment having two outcomes. Only two outcomes are there for a Bernoulli experiment or Bernoulli trial. For example, tossing a coin. If you are tossing a coin, you will get two outcomes only, that is head or tail. Getting head or getting tail. That are the two outcomes. Similarly, on throwing a die, getting an even number or an odd number. So you have to convert into two trials. On throwing a die, getting an even number one is an event, and getting an odd number is another event. So outcome. So that's like that we have to classify into Bernoulli trials. That experiment having two outcomes only. And these Bernoulli trials, any experiment having two outcomes, that is called Bernoulli trials. These trials involving the binomial distribution. So binomial distribution consisting of the following condition. Binomial distribution. This trial involves binomial distribution. So binomial distribution in binomial distribution, it has following conditions. That is, first condition, any Bernoulli trial results in a success or failure. Any trial results in a success or a failure. Any success results in a success or a failure. So any trial involves only success or failure. Then the number of trials are finite. Trials are finite in number, say n. Number of trials are finite in number, say n trials. And the third condition is probability of success for each trial is same. The number of trials are finite, say n, and are independent also. And finite and or independent trials. Third one is probability of success is same for each trial. probability of success is same for each trial. Okay, this is the three conditions for a binomial distribution, that is, it involves Bernoulli trial. So probability of each success, probability of success is same for each trial. Conditions are the number of trials are finite, say, and are independent. The probability of success for each trial is same, and each and every trial involves a success or failure. Okay. Now we will consider one random experiment, that is a Bernoulli experiment, that is tossing a coin. Getting head is the success. The event getting head is the success. The probability of success is denoted by P, which is equal to 1 by 2. On tossing a coin, you will get head or tail or the outcomes. For getting head, probability is 1 by 2, and that you consider as a success, and it is denoted by P. Similarly, getting tail is the event for failure. Therefore, the probability of getting tail is also 1 by 2, and it is denoted by Q. Success probability is defined by P, and the probability of failure is Q. So P plus Q equal to 1 by 2 plus 1 by 2, which is 1. So this is true for all Bernoulli experiments. P plus Q equal to 1, and also Q equal to 1 minus P. These two are standard forms of Bernoulli trials, and that trial is used in the binomial distribution. Now we will consider a random variable x. For the random experiment x, having n Bernoulli trials, the distribution function, or otherwise binomial distribution, this distribution function is otherwise called binomial distribution for n trials. For the random variable x is xi. X is the random variable x has n real values, 0, 1, 2, 3, etc. x, etc. n real values. For that corresponding probabilities P of xi, probability of xi, each x is, or probability of 0, x equal to 0. X equal to 0 means no head, all the outcomes are trial, n trials involving only tail, therefore q power n. In each trial, in all n trials, no head, therefore x equal to 0 means no head, that is q power n. n trials with the q, probability is q power n. Next, x equal to 1, that is 1 head, n minus 1 tails. 1 head, n minus 1 tails. Therefore, the probability for x equal to 1 is nc1, number of trials n, 1 head, so nc1, p power 1 into q power n minus 1, because we have 1 success, n minus 1 failures. And x equal to 2, probability of x equal to 2 is nc2, number of tiles heads are 2, therefore p square, and number of tails is n minus 2, therefore q power n minus 2. And so on. Consider the p of x equal to x is ncx. This is p of x equal to x is ncx, p power x. Number of success are x, number of failures are n minus x. Therefore, p power x into q power n minus x, and so on. And p of x equal to n is all the n trials having head, therefore p power n, success power n. So this table is called distribution table for binomial function, random variable x. So this is otherwise called distribution function or binomial distribution. In this, the standard form p of x equal to x is ncx is p power x into q power n minus x, where x equal to 0, 1, 2, etc. n. This denotes the binomial distribution function. Okay. Now, I am going to give the definition of a binomial distribution. Already we have seen the distribution function for the random variable x, and that is ncx into p power x into q power n minus x. This is the definition for the binomial distribution. See, definition of binomial distribution: for a random variable capital X said to follow binomial distribution if its probability mass function, is defined by p of x equal to x equal to ncx p power x into q power n minus x. where x equal to 0, 1, 2, etc. n. Number of trials n. Probability of success is p. Probability of failure is q. Therefore, the binomial distribution function is p of x equal to x is equal to ncx p power x into q power n minus x, where x equal to 0, 1, 2, etc. n. 0 otherwise, except all these n values, the binomial probability mass function is 0. Otherwise it is 0. N is the number of tries, p is the probability of success. And the binomial distribution is denoted by x is mapped onto b of n comma p. X is a random variable, is mapped to binomial distribution of n comma p, where n is the number of tries, p is the probability of success. It is a notation for a binomial distribution. Now I am going to define constant of binomial distribution. Constants of binomial distribution. First one is mean. Mean is always denoted by mu, that is nothing but np. Number of trials into probability of success, np is mean. Variance is sigma square notation. It is product of number of trials, probability of success, and the probability of failure. That is n into p into q. That is the constant of binomial distribution called variance, sigma square. Third one is standard deviation. Standard deviation is denoted by sigma, which is nothing but the square root of npq. The square root of the variance is nothing, you know that square root of variance is standard deviation. Therefore, sigma square is standard deviation is sigma, which is nothing but root of npq, square root of the product of number of trials, probability of success into probability of failure. And we know that the mean of the binomial distribution is always greater than the variance. Mean of the binomial distribution is always greater than the variance. This is an important note to remember, and we will solve the problems in the next video. Okay, thank you.